I guess we can move on to dynamic routing between capsules. Any questions about capsules? What is the idea here? What is the big picture? Previously, if you wanted to classify something, you would end up with a vector, and each entry of that vector was a neuron. Now you have a matrix at your last layer, and that's going to correspond to a group of neurons. So a group of neurons are going to decide together what should be the corresponding class, or is there an object of this type in my image? Yes or no? Is there a number 1 in my image? Is there a number 2? Same thing here. Previously, you were used to seeing filter maps. This is actually multiple filter maps, actually multiple feature maps. Previously, you had a single feature map. Now you have multiple feature maps. The same way that previously you had a single vector, now you have multiple vectors, which is going to give you a matrix. This is actually a 4-dimensional object. It's the best way to visualize it. So a group of neurons is going to give you a capsule. And there is also some ideas of attention coming in. Whenever you do a linear combination of your input, and then your C's have to add up to 1, that's going to give you a budget for your attention of 1 that you're spreading among your inputs. Any questions about this? Again, this is one of these ideas that you're not going to see them push the state of the art in terms of accuracy on ImageNet competition, but they're really nice ideas. Maybe in the future, you're going to see more applications. Actually, one of the applications that you're seeing here, this is really difficult. The network is seeing 2 numbers lying on top of each other. So this is really impressive, even today. Any questions? So the question is, can you explain again how the unit vector for V represents the properties of the entity? Yeah, sure. This is actually the entire idea. You have a vector per each output. So this is 1 output, and then you have 10 outputs, and each one is a 16-dimensional vector. What do you want out of your neural network? Or actually these output capsules, you want their norm to give you a probability. So you're decomposing your vector into 2 parts. One is the probability, one is its magnitude, its norm. The other one is a unit vector in that direction. This one, you are going to interpret as probability. That's what your interpretation is going to be. This other one, you're going to interpret it as the entity of the object. For instance, number 6 here could have an entity of its own. Number 8 could have another entity. And in an abstract way, you are representing those entities with 2 different vectors having a unit norm. Okay, this is what you want, but you have to enforce it. The probability, you're going to treat it as a probability in your loss. So that one is going to have the identity of a probability. The other one, you're going to try to make it represent the identity of your numbers by masking the rest of your numbers. Keep only the vector corresponding to number, I don't know what number it's going to be, 1, 2, 3, 4, 5, 6, or even 5 in this case, because you're starting from 0. So this is your number 5. Now you want it to represent or summarize the properties of number 5. And there is these ideas of autoencoders, which are gonna extend PCA type of ideas. Is that you're gonna summarize a very long vector, in this case 784, which is the number of pixels in your input image, and then you try to reconstruct it. It's gonna act as a bottleneck. And it means that throughout the training, the information should go inside this vector, whatever information that is present in a number 4 or in a number 5. Does that answer your question? Okay, perfect. Any other questions?
What's the name of the data set that has both numbers in there?
Actually, they're modifying MNIST.
Okay, gotcha.
Any other questions? Okay, perfect.